Hey everyone, Hihu here from LeetCode. Imagine you have two friend groups. Your job is to find the people who belong only to the first group and the people who belong only to the second. Anyone who appears in both groups isn't interesting. That's exactly what today's problem is asking us to do. Today we are solving LeetCode 2215. Find the difference of two arrays. It's an easy problem from the HashMap and HashSet section of the LeetCode 75 study plan. At first, this looks like a simple searching problem. But the real trick is realizing that we don't care how many times a number appears. We only care whether it exists or not. Once we recognize that, the solution becomes much cleaner. So before jumping into the algorithm, let's first understand the problem. We're given two integer arrays nums1 and nums2. Our task is to return two lists. The first list should contain every distinct number that appears in nums1 but not in nums2. The second list should contain every distinct number that appears in nums2 but not in nums1. Notice the word distinct. If the same number appears multiple times, we should include it only once in the answer. Let's understand this with an example. Suppose nums1 is 1, 2, 3 and nums2 is 2, 4, 6. Let's first look at nums1. The number 1 doesn't exist in nums2, so it belongs in our answer. The number 2 appears in both arrays, so we ignore it. The number 3 also doesn't exist in nums2, so we include it as well. Now let's check nums2. The number 2 already exists in nums1, so we skip it. The numbers 4 and 6 don't appear in nums1, so both of them belong in the second answer. Our final result becomes two lists. The first list contains 1 and 3. The second list contains 4 and 6. Now here's the obvious question. How do we efficiently check whether a number exists in the other array? Let's begin with the most straightforward solution. The first idea is pretty straightforward. For every number in nums1, we can search the entire nums2 array. If we never find that number, it belongs in our answer. Then we repeat the same process in the opposite direction. For every number in nums2, we search the entire nums1 array. If it doesn't exist there either, we add it to the second answer. There's just one more thing we need to be careful about. The problem asks for distinct numbers. So even if we discover the same value multiple times, we should add it only once. The logic is simple and it definitely works. Now let's see how we'd implement it. We start by creating two empty lists to store our answers. Now we iterate through nums1. For every element, we search the entire nums2 array. If the element is never found, we check whether we've already added it to our answer. If not, we add it to the first list. Once we've finished nums1, we repeat exactly the same process for nums2. This time, we search every element inside nums1. Again, if the number doesn't exist and isn't already present in our answer, we add it to the second list. Finally, we return both lists. The implementation isn't very complicated, but let's verify it with a dry run. Let's use the same example. nums1 contains 1, 2 and 3. nums2 contains 2, 4 and 6. We begin with the first element 1. Now we search the entire nums2 array. We check 2, not a match. Then 4, still not a match. Then 6, again not a match. Since 1 never appears in nums2, we add it to our first answer. Next we check 2. This time we immediately find it in nums2, so we skip it. Now we check 3. We search the entire nums2 array again. 3 never appears, so we add it to the first answer. Now we repeat the same process for nums2. The number 2 already exists in nums1, so we ignore it. The numbers 4 and 6 never appear in nums1, so we add both of them to the second answer. Our final answer becomes 1 and 3 in the first list and 4 and 6 in the second list. The algorithm works perfectly, but did you notice something? For almost every number, we are searching the entire other array from the beginning. Let's analyze the complexity. Suppose nums1 contains n elements and nums2 contains m elements. For every element in nums1, we may scan all m elements of nums2. Then we do the same thing in reverse. That gives us a time complexity of O of n into m. Now let's talk about space. Apart from the output lists, we only use a few temporary variables while searching, so the extra space complexity is O of 1. The real problem isn't memory. The real problem is that we are repeatedly asking the same question. Does this number exist in the other array? Can we answer that question much faster? Let's pause for a second and think about what we're really doing. Every time we pick a number, we search the entire other array just to answer one simple question. Does this number exist? Now here's something interesting. Do we care where that number exists? No. Do we care how many times it appears? Again, no. The only thing that matters is whether it exists or not. Once we realize that, the problem looks completely different. We don't need repeated searching anymore. We simply need a fast way to check membership, and that's exactly what a hash set gives us. A hash set stores only unique values, and it can tell us whether a number exists in almost constant time. That's the breakthrough. Instead of searching the entire array again and again, we build a hash set once and use it for instant lookups. So our algorithm becomes much simpler. First, we convert nums1 into a hash set. Then we convert nums2 into another hash set. Now every lookup becomes extremely fast. Next, we go through every unique number in the first set. If that number doesn't exist in the second set, we add it to our first answer. Once we're done, we repeat the same process in the opposite direction. This time, we check every unique number in the second set. If it doesn't exist in the first set, we add it to the second answer. Since a hash set automatically removes duplicates, we never have to worry about adding the same value twice alone. The algorithm becomes shorter, cleaner, and much more efficient. Now let's see how that idea looks in code. Now let's turn that idea into code. First, we create two hash sets, one for nums1 and another for nums2. These sets automatically remove duplicate values, so every number appears only once. Next, we create two lists to store our final answers. Now we iterate through the first hash set. For every number, we simply check whether it exists in the second hash set. If it doesn't, we add it to the first answer list. Once we're done, we repeat the same process for the second hash set. This time, if a number doesn't exist in the first hash set, we add it to the second answer list. Finally, we return both lists. The implementation is actually much shorter because the hash set takes care of both fast lookups and duplicate removal. Let's walk through the same example one last time. Nums1 contains 1, 2 and 3. Nums2 contains 2, 4 and 6. First, we convert both arrays into hash sets. In this example, the sets remain exactly the same because there are no duplicates. Now we start checking the first set. The number 1 doesn't exist in the second set, so we add it to our first answer. Next comes 2. It already exists in the second set, so we skip it. Then we check 3. Again, it isn't present in the second set, so we add it to our answer. Now we move to the second set. The number 2 already exists in the first set, so we ignore it. The numbers 4 and 6 don't exist in the first set, so we add both of them to the second answer. Our final result becomes 1 and 3 in the first list and 4 and 6 in the second list. Notice what changed. We never searched the entire array. Every lookup was a direct membership check inside the hash set. Let's analyze the complexity. Creating both hash sets takes one pass through each array. Then we iterate through each set exactly once to build our answer. Overall, every element is processed only a constant number of times. So the total time complexity is O of n plus mn. Now let's talk about space. We create two hash sets to store the unique elements from both arrays. In the worst case, they can contain every element from the input. So the space complexity is also O of n plus mn. Let's quickly recap. The brute force solution kept searching the entire opposite array for every single element. The breakthrough came when we realized that we weren't interested in positions or frequencies. We only wanted to answer one question: does this number exist? Once we looked at the problem that way, the perfect data structure became obvious. A hash set gives us fast membership checking and automatically removes duplicates. That's the interview pattern to remember. Whenever a problem only asks whether something exists instead of where it exists, think about using a hash set. And that's how we solve LeetCode 2215, find the difference of two arrays. If this explanation helped you understand the idea, don't forget to like the video and subscribe to LeetCode. Thanks for watching. This is Hihu signing off. Keep practicing, and I'll see you in the next one.